A test to determine whether a certain antibody is present is 99.1% effective. And this means that the test will accurately come back as negative if the antibody is not present 99.1% of the time. So I'm going to write that down as a probability. So that would be 0.991. Continuing, the probability of a test coming back positive when the antibody is not present, so that would be a false positive, that's bad, is going to be 0.009. And that is simply 1 minus this number. So if you take 1 and subtract 0.991, so this is the probability that the test works. 1 minus that's going to be the probability that the test doesn't work. It gives us this other value. Now continuing with the question, we're going to suppose the test is given to 7 randomly selected people who don't have the antibody. Part A asks, what is the probability that the test comes back negative for all 7 people? So here we are referring to this probability. Let's back up a little bit. Before we answer part A, well, what would the probability be if it was just, one person? So we'd say one test is negative. So to answer that, it would simply be this number right here. That's basically saying that you're taking one person who doesn't have the antibody, the test comes back negative, meaning that the test worked. It would be this probability right here. There's absolutely nothing to do. That's basically given information in this problem. Before getting to what part A is asking for, well, what if it was the probability that 2 tests are negative? Like, let's say we only had 2 people. Now this is where you have to use that multiplication rule. What you would do is take this probability and multiply it to itself. So that would be, you would take 0.991 and multiply it to itself like this. This is the same thing as 0.991 squared. And you can get this number right in a calculator, which is what I'm going to do. So I'm going to type in 0.991 and I'm going to square it. And I'll write out the whole decimal, but you get 0.982081. If it were 3 people, you would take this probability and multiply it to itself 3 times. But really that just changes this 2 to a 3. So it's very quick to go to a calculator, enter in this value, and cube it. You'd get a different probability, but that's how you'd get the answer. The trend is the number of people changes the exponent. I can now answer part A. If I want the probability that all 7 tests are negative, that's simply going to be take the probability and raise it to the power of 7. I'm going to do that in my calculator, and I'll round it to 4 decimal places because that's what my math lab wants. Okay, when I do that, I get 0.93886, but that 6 gets rounded up to a 7, and this is going to be the answer for part A. So the probability that all 7 tests come back negative was just a matter of multiplying this probability to itself 7 times. That's where this exponent of 7 came from, and this value I got simply by looking at my calculator. And to answer part B, this says, what is the probability that the test comes back positive for at least one of the 7 people? So to recap, we are told all 7 people don't have the antibody. If it comes back positive for somebody, well, that's exactly what a false positive means. They don't have the antibody, but the test said that they did, so we're talking about this category here. The observation to make is if you look at all tests are negative, what does it mean for this to not happen? It means that at least one came back positive. So these are complementary situations. So all 7 tests are negative. If that didn't happen, it must be that at least one came back positive. And this gives us a way to get our answer. The probability that at least one is positive is the same thing as 1 minus the probability that all 7 tests are negative. So while this sounds like a really difficult question to figure out, the fact that this means this didn't happen means we can take that probability from part A and subtract it from 1. So it's going to be 1 minus 0.9387. I'll do that in my calculator, and I get 0.0613. And this is the answer for part B.